Question 3 asks us first of all to regurgitate what the assumptions, the modelling assumptions are if you've got a projectile. Most people remember that there's no air resistance. That's why it continues going along horizontally as far as it does. No spin is another one. Constant gravity, that G is always 9.8. And got one more, sort of, if you wanted to think about one more, maybe there's no wind. Otherwise the wind takes it off to the side, so we've got no wind there as well. We're going off at 20 meters per second, and we're going at 30 degrees to the horizontal. So we can split that up very quickly into 20 cos 30 here and 20 sine 30 there. And if I want to know how long is it in the air for, how long is it in the air till it reaches down here, then I work on my vertical directions. Then it starts going up, as we just figured out, at 20 sine 30. And that's actually 10, isn't it? V, I don't know what speed it hits the ground at. It makes a big noise, bang there, but I don't know what it is, so I don't know what that one is there. I do know gravity. I do know gravity is minus 9.8. S, and it's T I'm trying to find out. So we must know what S is. And the point about S is you're back here at ground level. And so S here is equal to 0. So we're going to use an S equals ut plus half at squared. And we're going to get a quadratic in t to try and find out. So 0 equals 10t minus 4.9 t squared. I mean, you could factorize that as a quadratic, use a quadratic solver, or you could just factorize out the t. One answers t is equal to 0. Well, we know that. That's when you started back there. And the other answer is when t is equal to 10 divided by 49, which is a tiny bit more than 2, isn't it? 2.04 seconds. That's how long the ball is in the air. So we've got more to do on that, haven't we? The maximum height reached. So move down. So the maximum height reached, again, I'm going to change colour now. Again, we're going to go in the up direction here. Again, we've got u is equal to 10. At the maximum height at the top there, we know v is equal to 0. A is equal to minus 9.8. And it's s this time that we're trying to find out. And so this time I'm going to use a v squared equals u squared plus 2as. I've got 0 equals 100 minus 2 lots of 9.8s. So s is 100 divided by 2 lots of 9.8, and that's 19.6. So that one there's 5.1 meters. And the last bit, find the horizontal distance. The horizontal distance this time, change colour again. So the horizontal distance, we know is starting off that way. It was a long time ago, but at 20 cos 30. And we know the time. The time we're flying for, we got earlier, was 2.04, wasn't it? And so the distance travelled, we just times those two things together, and that gets us 35.3 meters. That's the distance travelled from here, well, from there to there. I suppose it's going to bounce and go on like that, but we don't care about that.